The probability that a randomly selected female aged 60 years old will survive the year is 99.186% according to the National Vital Statistics Report. What is the probability that at least one of 500 randomly selected 60-year-old females will die during the course of the year? So we want the probability that at least one of them will die during the year. So that means that either one could die, or two, or three, or four, or five, or all 500. This probability will get really complicated if we think about it this way. Whenever you are dealing with at least one probabilities, you need to use the complement rule. So now let's think. We want the probability that at least one dies. And for the complement rule, you find the opposite event. The opposite of at least one female dying would be that none of them die. So we can find the probability that none of them die, and then use that to find the probability that at least one dies. So now let's look at the complement rule. The probability that at least one dies is 1 minus the complement or the opposite event, and this would be the probability that none die. So now we need to find the probability that none die. In the problem, we aren't given the probability in terms of death, we are given the probability in terms of survival. So we can say that none dying is the same as all surviving. So we can rewrite the probability of none dying as all surviving. And because we know the probability that one female will survive, that means that we can find the probability that all 500 randomly selected females will survive the year. As we have discussed in some previous examples, the women surviving the year are independent of each other. So we can just multiply the probabilities that the first survive times the second times the fourth times the fifth, all the way up to the 500th female. Instead of multiplying the probability that one female survives 500 times, we can just use exponents. We know the probability of one woman surviving is 0.99186. We have to do this for the first and the second and the third, all the way up to number 500. But again, we can just use an exponent of 500 to denote that we are multiplying 0.99186 500 times. Now type this into your calculator and round to 4 decimal places. We get 0.9832, and this is the probability that at least one of 500 randomly selected 60-year-old females will die during the course of the year.